So we finished up the last video by computing a solution to the dual using complementary slackness, and we were basically building this little table right here. And so we're going to try a couple more examples. And so let's go ahead and take a look at our example 2 here now. Example 2. It'll be similar. Suppose we have a max with C equals 2, 4, 3, 1, and our B is equal to, I guess I should have put A first, 12, 7, 10, and our A is equal to 3, 1, 1, 4, 1, minus 3, 2, 3, 2, 1, 3, minus 1. Okay, and now suppose I also know what the solution for the primal is, and we know it's 0, 10.4, 0, and 0.4. And just for the sake of argument, our Z is equal to 42. Okay, so can we find the solution to the dual? Find the solution to the dual using complementary slackness. Okay, and just to make things a little bit easier, we'll give you a hint. First and third constraints are binding. First and third constraints to the primal are binding. Okay, and the second is not. Good. Okay, so now what is this hint giving us? Actually, before we start that, maybe we should draw out our little diagram like we had before. Whoops. So my diagram, I gotta get rid of this thing here. Our diagram is going to look like the following. We're going to have x1, x2, x3, x4, and then I've got 3 other variables, right? So that's going to be s1, s2, s3, and then underneath that I've got 4 excess variables and just 3 y's. And let's see, what else do I know? I know that this is 0 and I know this is 0. 10.4, 0.4. I know that the first and third constraints to the primal are binding. What does that mean? S1 and S3 are 0, and S2 I know is greater than 0. Okay, so what does that tell me about my solution to the dual? Well, I know that y2, why am I doing this here? Okay, y2 must be equal to 0. There we go. I know that E1, whoops, not E1, but I know E2 must be 0, and I know that E4 must be 0, right? Good. All right. And so what does that say about our system of equations then? Well, if I look at A, maybe I should write A transpose off to the side here. A transpose is equal to 3, 1, 2, 1 minus 3, 1, 1, 2, 3, and 4, 3 minus 1. Okay, what this is saying is, let me draw that in red. What this is saying is that 3, 1, 2 and the equation for 3, 1, 2 and the equation for 1, 2, 3 have an excess variable, and so I'm going to take those out for the moment and just use the other 2 equations. And so then I know that y1 minus 3y2 plus y3 is equal to 4, and 4y1 plus 3y2 minus y3 is equal to 1. Okay, and what else do I know? I know that y2 is equal to 0, and so that just leaves us with the system y1 plus y3 equals 4, and 4y1 minus y3 is equal to 1. And so now if we just add straight down, we see that 5y1 equals 5, and so therefore y1 is equal to 1. And so what will y3 be then? Y3 would be 3. Good. And so there is the solution to the dual. We have a 1, 0, 3 is the solution to the dual. Good. Now, at this stage, you could find what S2 is and what E1 is and E3, but we weren't asked that. We were just asked to find the solution to the dual. Good. Okay, so we've got a little bit of time left. Let's go ahead and do one more example here. So in this example, example 3, I'm actually going to be giving you a couple of tableaus. Let me make that a big 3 there. Example 3, I'm going to have two tableaus, x1, x2, s1, s2, x1, x2, s1, s2. Good, and over here it will be minus 2, 0, 0, 0, 0, 0, 0, 2, 0, 12, 1, 2, 1, 1, 1, 0, 0, 1, 6, 13, 1, 0, 1, minus 1, 1, minus 2, 0, 1, 6, 1. Okay. And so what I want to do is I want to solve the dual. I want to give the full solution in this case. So I want to give solutions to all the variables, E1, E2, and Y1 and Y2. Good. So can we do that? So this is the optimal solution. And so from our optimal solution, I see that x1 is equal to 6. x2 is equal to what? x2 is equal to 0. s1 is equal to 0. And s2 is equal to 1. Now from complementary slackness, I know that E1 must be equal to 0, and also Y2 must be 0. I could have pulled that off of here though, because I know that these are the solutions to the dual as well, so that's going to be 2, 0. And then finally, what is E2 equal to? Can we figure out what E2 is? Where's my E2? E2 is going to be coming from my second equation from the dual. It turns out that E2 is actually going to be this value sitting right here. We'll see that later, but you can compute it as well, and we should find that E2 is equal to 0. And so what I wanted to note here is that it is possible that while ei times xi equals 0, it could be that both variables are equal to 0. Both E2, gosh darn it, E2 and x2 are equal to 0 in this case. In case that doesn't happen often, it happens sometimes, and actually you can see what's going on in this problem, right? What's happening is this, does this tableau represent a unique solution? It's been a while since we've asked that. The answer is no, because we have a 0 right here in a non-basic variable, and I am able to pivot into this column. Very good. So this has multiple optimal solutions. Okay, so this is kind of a special case, but that's just 2 examples of using complementary slackness to solve for the dual.